Bracket AP review. We're doing 2009 BC free response 3, which is a calculator problem because in 2009 free response 1, 2, and 3 were calculator problems. A diver, this is my terrible diagram. It's actually not that much worse than the AP one though, which they specifically note is not drawn to scale. So a diver leaps from the edge of a diving platform into a pool below. The figure here terribly shows the initial position of the diver and her position at a later time, which is like when she's falling in the air. At time t seconds after she leaps, the horizontal distance from the front edge of the platform, from here to here, is x of t, and the vertical distance from the water to her shoulders is given by y of t. So the water level to her shoulders. They're both measured in meters. Suppose that the diver's shoulders are 11.4 meters above the water when she makes her leap, meaning that y of 0 is 11.4. And that we have this dx dt and this dy dt that are given to us for the window from 0 to a, where a is the time that the diver's shoulders enter the water, because obviously she's no longer in free fall once she's in the water. Part A. Find the maximum vertical distance from the water's surface to the diver's shoulders. Okay, so essentially what you're trying to find is you're trying to find this essentially wherever the shoulders are at the highest, right? So like if this is tracking her shoulders, whenever her shoulders hit it, they're very highest, right? So if you're trying to find a maximum for something, the way you do that is by setting its derivative equal to 0, right? So what we need to do in part A, right? We need to know where dy dt equals 0. Now there's two ways to do that. One way is to use your calculator to do it. The other way is that this is pretty simple linear equation. So one thing to note here, right? So I did put this into x1t and y1t in my calculator, but when you go to second calc in parametric mode, you'll note there is no second calc intersect. So what I want you to note is that although, so I have this x1t and I have this y1t, just noting that for my own benefit because I'm going to use them for things, I can't find where this graph intersects 0 easily in my calculator. Now, normally I'd say that's not a big deal. What I would do is I would switch modes and I'd go to function, right? I'd go to function. And then in my y equals, I would put this in, but with an x instead of a t, and then I can second calc intersect because I'm in function mode. The thing here is that this is such a straightforward equation, and it's so easy to solve, that I'm going to argue the easiest way to do this, even though it's a calculator section, is to just do it really quickly by hand. Because if you set this equal to 0, right, and you subtract the 3.6 over and divide by the negative 9.8, you're going to get that t is whatever a 3.6 divided by a 9.8 is, right? Which is not going to be awful at all and is easy to find, right? So while it's possible to do second calc intersect in function mode, I'm going to argue that here it's just really not worth it. So you're going to get that this t is approximately 0.3673469, right? And I'm going to store that. So I'm going to store that as, I'm going to store it as b, and the reason I'm going to call it b is that they already used a in this problem, so I should avoid using a letter that's already been used. So I did stow, and I'm going to pick alpha b, and I'm going to make a note for myself that that's b, okay? So if I want the maximum distance, right, I know that y of 0 was 11.4 meters, right? And I seem to want y of that thing I called b. Well, in order to find that, I'm just going to do the first fundamental theorem of calculus. If I integrate this dy dt, which is the same as y prime of t, right? In fact, actually, we can call it that if that makes you feel better, y prime of t with respect to t, right? If I integrate this from 0 to b, I'm going to get y of b, which is the answer I want. That's the maximum vertical height of her shoulders, minus y of 0, which is that 11.4. So essentially what I'm going to do is I'm going to do y of 0 plus the integral I'm going to make my calculator do from 0 to b, and that should give me my maximum height, right? So I'm going to go ahead and do that in my calculator. Now, because I'm back in parametric mode, right? So this is going to be an 11.4 plus function integrate y1t with respect to t from 0 to the thing I stored as b, right? And your calculator notation is never going to matter to the AP. You just need to know how to get this right. So I'm going to hit math 9 for my function integrate, right? Vars over to y vars, pick parametric. I want y1t, comma, with respect to t from 0 to alpha b, right? And I'm going to hit enter, and I should get that that's a 12, sorry, my marker's kind of dying, 12.061 meters, right? So that's how high she gets, which is not, that's pretty high up, so good for her. All right, cool, so that's my part A, right? And I'm going to hopefully secure a slightly better marker for part B. All right, part B. Find A, the time that the diver's shoulders enter the water. Okay, so again, notice I specifically didn't use A for that other value because there's an A in the problem. All right, so they want to know when the diver's shoulders hit the water. Okay, so here's what I know, right? I can actually find the position by integrating this because this is actually pretty simple to integrate. So if we look at part B, right, we have that dy dt equals 3.6 minus 9.8t. Well, that's a separable differential equation, right? I can actually make this dy equals 3.6 minus 9.8t with respect to t, and I can integrate both sides, right? Now, my calculator can't do this because it doesn't have bounds, but that's okay, right? So I'm going to get that y of t, right, is a 3.6t minus a 4.9t squared plus some constant, right? Well, I can plug in the 0 and the 11.4 to find that constant. I'm very quickly going to find that that constant is in fact 11.4 because y of 0 is an 11.4, which is going to knock out all of these plus c. So my c is an 11.4. So I get that my y of t is negative 4.9t squared plus 3.6t plus 11.4. Now, once I have y of t, right, I want to know when y of t is equal to 0, right? So this is going to be one of those times that it is much easier to either use my calculator or use the quadratic formula because this is a quadratic formula, which is sort of nice. So I'm going to erase my little diagram because I don't think I need it anymore, and I'm going to erase these guys. So I want to know when y of t equals 0, right? That's going to be the time that is my a. So I can do that in a bunch of different ways. You have a calculator, so you should use it. They really don't need you to show any work here because a lot of us have a calculator formula that will tell you what t is by doing the quadratic formula in a program in your calculator, which is totally fine. They really just need you to find when this value happens, right? And so I can do that in a couple different ways, right? So if you have a program in your calculator, right? So for instance, I have a program that I call quad in my calculator, right? And that's the quadratic formula program. And if I put in a is negative 4.9, and b is 3.6, and c is 11.4, I'm going to get two answers, right? So I put in my a, b, and c, right? I'm going to get two answers. One of them is not logically going to make sense in the context of this problem, right? So the negative time doesn't make sense because that would be before the problem even starts. And it makes sense that there are two zeros here because it's a quadratic. So the only possible zero that makes sense is the 1.936 seconds, presumably, because, yeah, so meters per second. Okay, so second. So that's fine. So one way to do it is the quadratic formula. Another way to do it is to put this in as your, so another option, right, is to put this in as your y1 in function mode, right, in function mode, and then you can do second calc 0, and that's totally fine, but it's not a thing you can do in parametric, right? Another thing you could do is just do the quadratic formula by hand, which is not super fun, and then type everything in into your calculator, and you'll get the same value. Cool. Part C. So, and because they called it A, right, I should probably say that this is A, right? So make it clear that that's A, because A was what they called the time. Cool. So, part C. Find the total distance traveled by the diver's shoulders from the time she leaps off the platform to the time she enters the water. Well, if we picture what that looks like, and of course I did just erase the picture because that fits. If we think about what that looks like, that's the arc length, right? So if we look at that, so here are her shoulders, right? And she jumps in the air and her shoulders do this. Well, that's, if you want the length of this curve, that's called arc length. So what they're asking you to do is find the arc length. So they're asking you to find the arc length from 0 to this, from time 0 to this 1.936, etc. Now, one thing to note here is that I did not, because of the way I have this in my calculator, I did not set it to automatically store. So that's kind of annoying. But what I can do is I can either do the quadratic formula again, like type it by hand, or I can do the second calc 0 and store it that way. Right now, or I can edit my program to actually store it for me, right? If I go to my quadratic formula program, so it displays two answers, right? And if I wanted, I could probably get it to store one answer as D and one answer as C, right? There's nothing wrong with that. However, sorry, as E, not C, because there's already a C. So there's nothing wrong with doing that, but then you'd have to make a note that that's what happened. So I had a negative 4.9, a 3.6, and an 11.4, and we'll see if this works. Nope, it gives me an error. So I would have to add that as a separate line, which is not the most fun thing in the world, but that's okay. So anyway, it's good to know how to do basic programming stuff in your calculator. Because I'm lazy, I'm just going to go ahead and do second. I'm going to show you the other option here, is if I had switched back to mode and function, right? If I put in the negative 4.9 x squared plus 3.6 x plus 11.4, right? And if I graph this, I can say, oh, I'm in a weird window. Hold on, I can zoom 6, and I can second calculator or second calc 0 rather. So that's the 0 I want. So I can do second calc 0. Scroll over. I get a 0 here. That x is now the value I want, so I quit out of that, and I can store that x. So if I hit x, I can store that as a, and that actually is a. So now we have that value stored, so we should always use a stored value or every single digit. You never want to use an approximate value when you're calculating. So for c, we want the arc length from 0 to a. Well, the arc length is the integral from 0 to a of the square root of dx dt, quantity squared, plus dy dt, quantity squared, with respect to t. Basically, it's the integral of the speed, right? So what that's going to look like, I just have to write that out. I don't have to do anything else, and then I just need to give an approximate answer, right? So that's my job, right? And that'll be in meters because it's how far it traveled. So when I type this in my calculator, I'm going to do function integrate, right? Square root of, open the parentheses, x1t quantity squared plus y1t quantity squared, close the parentheses, comma, with respect to t from 0 to the thing I stored as a, right? So you have to know how to enter this in your calculator. And you can see that sometimes on these calculator problems, the part that's more tedious is actually making sure you know that you're in the right function to do what you need to do. So I put the square root, I go to vars over to parametric, right? I'm going to pick x1t quantity squared plus vars over to parametric, get y1t quantity squared, close the parentheses, with respect to t. Oh, hang on. I'm in the wrong mode. Let's go back for a second. Let me show you how I knew I was in the wrong mode. I'm in the wrong mode because when I went to press with respect to t using the x comma t comma theta comma n button, I got an x, which means I'm in the wrong mode. There are two ways to get t. You can either switch back to parametric, and if I do that, then when I press this button, it'll give me a t, or I could have found the alpha t. Either one of those is fine, from 0 to alpha a. All right, so I have my x1t quantity squared plus my y1t quantity squared all inside a square root with respect to t from 0 to a, and I hit enter, and my arc length should, after a little bit of thinking, come out to a 12.946 meters. All right, cool. Part D. Find the angle theta, theta being between 0 and pi over 2, which just means it's an acute angle, between the path of the diver and the water at the instant the diver's shoulders enter the water. Okay, so let's picture what this looks like, right? So we have this diver entering the water, right? So the diver's entering the water at some angle, right? And they said it was between 0 and 90, essentially, degrees, or 0 and pi over 2 in radians, which means that it has to be this, it has to be this side, essentially, right? Or the other side if the person were angled this way, right? Like divers can enter the water straight up and down. They can enter the water at an angle this way. They could enter the water at an angle this way. And I know there's terms for that, but I don't know what they are. But because they said that the theta has to be between 0 and pi over 2, it's an acute angle, right? So I know that this measurement is essentially whatever x is, right? X of t, right? And this measurement is y of t, right? Cool. So if we want the angle of this person's shoulders, right, at the moment when they enter, essentially, like, let me put this a better way. This is my change in x and this is my change in y, right? What they're asking me to do, essentially, is I can say that the slope, right, equals the tangent of this quantity. So the tangent of that theta equals whatever my change in y, which is the opposite over my change in x is, right? Or equals dy dx, for lack of a better way to say it, which we know is y prime of t on top of x prime of t, right? So essentially, what we need to find is we need to say that the tangent of theta, sorry, my bad, didn't derive a thing. We want to find specifically the angle, right? So my theta, sorry, is the inverse tangent of whatever y prime of a over x prime of a is, right? Because that would be the slope, right? So that's all I have to do, and I can evaluate y prime of a over x prime of a, right? So my y prime of a, so essentially there's a couple different ways to do this, right? But I know that if I go back, so I'm currently in my parametric mode, right? So if I go to trace, right, and then if I put in alpha a, oh, it's outside of my window. Sorry, let's zoom 6. Okay. If I go to trace, right, and I hit alpha a, it'll give me both of those quantities, right? So now stored as x is going to be a 0.8, right? And stored as y is going to be the negative 15.3753, et cetera, et cetera. So if I quit out of this, if I do alpha y divided by alpha x, that's going to give me this quantity. So what I want is I want the inverse tangent. So my theta is the inverse tangent of this negative 19.21913 right? So I'm going to store that as alpha c for a sec so I can use it. I want second tangent of the thing I called alpha c. And there you go. So when I did that, I got that my theta is a negative 1.518 radians, right? But they gave us that the window that they wanted it to be between 0 and pi over 2, right? So the reasoning behind this is essentially that what they're asking me to say is what is the acute angle that is equivalent to this, right? And the acute angle that's equivalent would be the positive 1.518 or 9, depending on if you round or truncate. And you don't need to say radians because that's one of the only times you don't need a unit, right? So again, because the idea is that this negative refers not to the size of the angle, but rather to the direction, right? So so it doesn't matter which way you're rotating, right? So in this case, this angle would be rotating essentially clockwise rather, which is a negative rotation, but it doesn't matter which direction. We're just talking about the actual quantity of the angle, which is why it's positive.